All right, for a few of these problems, I'm going to show more than one way to solve. So that explains some of the length of the video. And before we get started, every problem involving an angle gives us an angle in degrees. So the first thing to do is make sure that you switch your calculator to degree mode. So press mode down here. Radian is highlighted anytime your calculator gets reset. So you need to change that into degree mode, and then you'll be all set up. Okay. So first one, a plane is flying within sight of the Gateway Arch in St. Louis, Missouri at an elevation of 35,000 feet. The pilot would like to estimate her distance from the Gateway Arch. She finds that the angle of depression to a point on the ground below is 22 degrees. So the first thing is to draw the picture. So we have a right triangle here. The plane's got to be up here in the sky, right? She is looking down at some point on the ground. The elevation is 35,000 feet. And the angle of depression, which is always, imagine, it's always from the horizontal. So imagine you're looking straight out and then you look down 22 degrees. And we talked about this in the notes. Angles of depression are alternate interior to angles of elevation. So I would like the angle to be in the triangle. So I just translate it down here. Most common mistake is putting it up here, 22 degrees. That would screw up your triangle. Okay, so part A says, what is the distance between the plane and the arch? So the distance between the plane and the arch, which is down here, is this hypotenuse. So let's just call that x. And then part B says, what is the distance between a point on the ground directly below the plane and the arch? So that's, I'm just going to call this y. That's talking about this horizontal leg. Okay, so part A, I want to find x. I have an angle, I have opposite, I have hypotenuse. So I'm going to set up the sine of 22 degrees is equal to opposite over hypotenuse. We need to solve this for x. So you multiply x over to this side. And then you divide by sine of 22. So the exact answer for x is 35,000 divided by the sine of 22 degrees. We are going to approximate always to 3 places. So again, I'm in degree mode. 35,000 divided by the sine of 22. So that is, just get this so it's split. So that is 93,431.351, and I label that in feet because the elevation was given in feet. Part B is solving for y. The distance between a point directly below the plane on the ground and the arch. So y is adjacent to 22. You should always use the given side length. You don't want to use your rounded x, or you don't want to use x if it's wrong or something, if you messed up. So go back to 35,000. So we have opposite and adjacent, which means we need to set up tangent of 22 degrees equals 35,000 divided by y. I'm going to multiply y over to this side and divide tangent of 22 over to this side, just like I did in part A. And then I'm going to type that in, or I could also I just need to make one adjustment here. Just change sine to tangent. So that distance is approximately 86,628 points. So 0.39 is going to round up to 0.40. And that's also labeled in feet. Okay, next question. A laser beam is to be directed toward the center of the moon, but the beam strays 0.5 degrees from its intended path. So let's draw that first. So we have the moon, center of the moon, the beam. I assume we're talking about some laser beam from Earth. So here we go, Earth. So this is supposed to go directly to center of the moon, but the laser beam has strayed 0.5 degrees from its intended path. Part A says, how far has the beam diverged from its assigned target when it reaches the moon? So not when it gets to the center of the moon, but because that's in the moon, right? But we're talking about the surface of the moon. So when the beam is supposed to have hit right here, how far has it gone off target? Basically, let's call that distance y. So basically, how long is y? It says the distance from the Earth to the moon, so this horizontal direct distance here, is 240,000 miles. So for part A, I want to solve for y. I have opposite and adjacent, because remember, hypotenuse is always across from the 90-degree angle. So I'm going to set up a tangent function again. The tangent of 0.5 degrees is equal to y over 240,000. And then to solve for y, I only have to multiply 240,000 over to the other side. And then I'll type in what I got. So y is approximately 240,000 times the tangent of 0.5. So that is how far off course? We're 2,094.448. The unit is miles because that's what the 240,000 was measured in. So that's how far off course the laser beam has strayed by the time it reaches the moon. Part B says the radius of the moon is about 1,000 miles. Will the beam strike the moon? So it's already 2,094 meters off course, and this distance here, the radius is 1,000. So no, because by the time it hits the moon, it's more than 1,000 meters off course. So I'm going to say no, or not meters, miles. No, because the laser is already more than 1,000 miles off course. So since I know that it's 2,094 miles, it's going to miss the moon by what? Not 1,094 miles. Okay. All right, 48. Sometimes drawing the picture is the hardest part for people, so it just takes some practice. From the top of a 200-foot lighthouse, the angle of depression from to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? So we have this lighthouse that's 200 feet. And there's some ship out here on the sea. So I like to label things just so you don't have to do this, but I just kind of like to keep things straight. So lighthouse to a ship, 200-foot lighthouse, angle of depression. So if you were standing at the top of the lighthouse, remember the angle of depression is always from the horizontal. It's always outside of the triangle that you're drawing. That angle of depression is 23 degrees. And remember, that's alternate interior to this angle right here. So angles of depression are the same as angles of elevation. You can put them in the same position. And the question is, how far is the ship from the base of the lighthouse? So let's just call that x. We're using tangent again because we have opposite and adjacent. So this is a short little problem. The tangent of 23 degrees is equal to 200 divided by x. X is in the denominator, so you multiply it out, and then you're going to divide by tangent of 23. We do that a lot, so I don't always show that step like I did in the first problem, but hopefully you get used to doing that or show the two steps. 200 divided by the tangent of 23 is equal to about 471.170 measured in feet because that's what the lighthouse height was measured in. All right. A leaning ladder. This is a classic right triangle problem. So a 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. So let's lean our ladder against a building here. Here's the building. The ladder is 20 feet, so that's the hypotenuse. The angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? So let's call that x. And then we have to pick the correct trig function. So now we have opposite the 72 degrees and we have hypotenuse. So that's sine. Sine of 72 is equal to x over 20. And I just multiply by 20 to get x by itself. And put this into my calculator. So 20 times the sine, 72, 19.021. Label that in feet, approximately equal to x. Always label your answers anytime we have units involved. Okay, another ladder problem. So this one says a 20-foot ladder again is leaning against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle of elevation of the ladder? And then also, how high does the ladder reach on the building? So let's draw the picture first. Same idea as the last picture. We have, again, a 20-foot ladder. We know that the base of the ladder is 6 feet. I don't really do a good job of drawing to scale here, but 6 feet from the wall. What is the angle of elevation? And then what is the height of the building? So first, let's find the angle of elevation. We have adjacent and hypotenuse. So the cosine of theta, whatever it is equal to 6 over 20. You can reduce that if you want, 3 over 10. We're going to use a calculator, so it doesn't really matter. Then remember what we do if we want to find theta. I want to get theta by itself. I undo a cosine by doing an inverse cosine of both sides of the equation. Our AP exam is big on inverse functions, so that's the reason I show this. Inverse cosine cancels with cosine to leave you with theta. And then I'm going to type this into my calculator. Inverse cosine is second cosine. That pulls up that little inverse cosine of 3/10. And remember, that's inverse notation. It doesn't mean like cosine to the -1. Because I'm in degree mode, this is in degrees, this answer. So this is 72.542. 72.542, and you need to label with degrees. If you don't label with degrees and you just write the number, it's assumed to be radians, which is 72 radians is a lot different than 72 degrees. All right. Oh, sorry. How high is the ladder against the wall? So even though you have an angle, don't use the angle because you just rounded it. Don't use the angle to help you figure out x. We can figure out x without trig. We can just use Pythagorean theorem. X squared plus 6 squared is supposed to equal 20 squared. So x would equal the square root of 20 squared minus 6 squared. And we'll see what that comes out to. So about 19.079. And x is labeled in feet, just like the ladder. Okay, on to 51. A 96-foot tree casts a shadow that is 120 feet long. What is the angle of elevation of the sun? So we have a 96-foot tree casting a shadow. So I'm going to put the shadow. Now, a shadow's on the ground. So this is the shadow. Sometimes people get mixed up and make it the hypotenuse, but shadows aren't like floating in the air. So the shadow is 120. And what's the angle of elevation to the sun? So we know angles of elevation are here, but just to explain that a little bit more, if this is the tree, right, this is the top of the tree and its shadow is this way, the sun must be up here. So angle of elevation to the sun is like on the shadow side, looking up at what side? Looking up at the sun, which has to be on this side. All right, so we have opposite and adjacent. That means that tangent of theta is equal to 96 over 120. And again, I could reduce that fraction, but we're using a calculator, so there's no real need to reduce. And I don't want to risk doing the math incorrectly when I reduce. So I'm going to inverse tangent both sides. Inverse tangent cancels with tangent, leaves you with theta equals, and we're going to type this into the calculator. So second tangent, 96 divided by 120. And we get 38 point, this is 659 is going to round up to 660. So 38.660 degrees. And that's it for 51. For 52, a 600-foot guy wire is attached to the top of the communications tower. A guy wire is the wire that you see connects to the ground to the top of something. Like I feel like we see them a lot with maybe utility poles and things. If the wire makes an angle of 65 degrees with the ground, how tall is the tower? So we have this tower. We don't know how tall it is. We have a guy wire connected to the ground that goes up to the top of the tower. That thing is 600 feet. We have an angle between the wire and the ground, also known as an angle of elevation, 65 degrees. How tall is the communications tower? So we'll just call that X. So again, this is the guy wire. I'm not sure why it's called guy wire. Something to Google. Okay, so we have opposite and hypotenuse. This is going to be the sine of 65 degrees equals opposite over hypotenuse. And I just multiply by 600 to get X by itself. And type this into my calculator. So the tower is 548.785. 540, I think I said that wrong. 543.785 feet for the height of our tower. 53, elevation of a kite. A man is lying on the beach flying a kite. Okay. He holds the end of the kite string at ground level. This is strange. And estimates the angle of elevation of the kite to be 50 degrees. If the string of the kite is 450 feet long, how high is the kite above the ground? So, interesting scenario here. So, we've got this guy on the beach here. We know the string of the kite would be the hypotenuse, so that's 450 feet long. The angle of elevation is about 50 degrees. How high is the kite above the ground would be this vertical distance. This is the kite up here. All right, so opposite hypotenuse, we are using sine again. The sine of 50 degrees is equal to X over 450. Multiply 450 over to the left side. And type this into the calculator. 344.719 rounds up to 720. So 344.720 measured in feet, approximate value for X. All right, so let's take a look at this problem. So a woman, they give us the picture for this. That's nice. We might have to add to it. A woman standing on a hill sees a flagpole that she knows is 60 feet tall. Okay, so that's 60. The angle of depression to the bottom of the pole is 14 degrees. That's marked in for us. Angle of elevation is 18 degrees. Find her distance X from the pole. So that's got to make a right angle. You always measure your distance from something at a perpendicular length. What we don't know is how the 60 feet is split up. So it's not 30-30 because these aren't the same angle. So we don't know if it's like 50-10 or what the split up is. So I'm just going to say this. If this distance is y, if this is y feet, then this is the rest of the 60. Meaning if this is 40, this is 20. If this is 30, this is 30. So the rest of 60 is 60 minus y. We have two right triangles here that we need to work with. Both have an opposite and an adjacent side to the angle. So one trig equation is the tangent of 18 degrees is equal to y over x. The other trig equation is the tangent of 14 degrees is equal to 60 minus y over x. And we have these two tangent equations. The goal is to find x, right? So we want our equations, when we put these equations together, we want them to still have x in the variable. So I'm going to multiply x to the other side. X times tangent of 18 degrees equals y. Multiply x over here. So x times the tangent of 14 degrees equals 60 minus y. So let's solve this equation fully for y. So if I do that, I like to, when I see minus y, I like to add y to the left side and then subtract this term to the right side. So it's going to be 60 minus x times tangent of 14. That just saves me from saying minus 60 and then having to divide by a negative and mess that up somehow. So I just like to flip things around. This goes here, this goes here. And if both of these equations are equal to y, then I can set the equations equal to each other. So it has to be true that x tangent of 18 degrees is equal to 60 minus x times tangent of 14 degrees. All right, and we've had problems like this before when we were in our logarithms unit. When you have two terms that have x's in them, you need to get the x terms on the same side. So let's keep x tangent of 18 degrees over here. Let's add x tangent of 14 degrees to the left side, and we'll keep the 60 over here. And then the reason we get the x's on the same side is so that we can factor an x out, which makes this the quantity tangent 18x plus tangent of 14. And that's helpful because now we can isolate x by dividing by the parentheses. So the exact answer for x is 60 divided by tangent of 18 degrees plus tangent of 14 degrees. We would like to approximate the answer for x. So you just have to be careful about typing this in. Let me split screen this. You don't need a million parentheses, but you do need some. So 60 divided by, I need to put parentheses around the denominator so that the calculator knows that this addition should happen first and then it should divide after that. So parentheses, tangent of 18. Now I need to close parentheses around that angle so the calculator knows that's it, tangent of 18 plus tangent of 14. Same thing, close that angle. And then you have to close parentheses again because you've got these outer parentheses here. So you do have to put a little thought about how you enter this stuff in. Otherwise, calculator does the order of operations that you've assigned and can easily get you the wrong answer. So this is 104.485. And we're measuring this in, I think it was feet. Yes. The 60 was 60 feet. So that's my answer for that one. All right. This next one, I think I'm going to have time for one more before I get cut off, and there will be a part 2 video for the last few problems. A water tower is located 325 feet from a building, so they've put that down here, but also know that that's the length of this middle segment here. From a window in the building, an observer notes that the angle of elevation to the top is 39, angle of depression to the bottom is 25. How tall is the tower? So they want us to find this entire length. How tall is the tower? And how high is the window? So I don't know how tall the tower is right now, but there are two right triangles here again. Let's call the first right triangle the first leg x, and let's call the bottom leg y. So we're going to set up two tangent equations again. We can say, and then the height of the tower is whatever x plus y is. So let's set up our first tangent equation because I have opposite and adjacent. The tangent of 39 degrees equals x over 325. And the other equation is the tangent of 25 degrees equals y over 325. Solve for x. I'm not going to type this in yet, but x is 325 times tangent of 39. Y, same idea, 325 times tangent of 25. That's equal to y. And we just said, how tall is the tower? So how tall is the tower? Tower height is equal to x plus y, which is about equal to, this is where I type this in. You can do this on the AP test, by the way. As long as you've defined exactly what x is and exactly what y is, you can just say x plus y without having to write this all again. If you're not sure, then write it all out. But as long as you're clear in your work, you can save yourself a little bit of writing. So I'm getting 414.730. And that's measured in feet? Feet, yes. There's a follow-up question. How high is the window? So how high is the window? Well, that's just the length of y. So y, I just want to make sure I type in the right one. Write this down. The window height. The window height is just equal to y. And y was 325 times the tangent of 25. So that's 151 points. That's going to be 550. All right. I'm going to stop there for this video because the bell is going to ring in a couple minutes. The second video has the remaining problems.